Welcome back to Pre-Algebra, Chapter 4, Section 1 in this book. It is called Factors and Prime Factorization. Now you probably already learned this in middle school, but you're probably not good at it. And the reason why is not the math, it's the English. These words, they picked all the wrong words if they wanted people to understand math. They just got to make me queen of math. I'll come in and straighten it all out, and we'll call things what they are, and everybody will understand it better. All right, so the first word is factors. So the factors are two numbers you can multiply to get another number. So 2 and, I said it the wrong way, 3 and 2, pointing to the wrong one, are factors of 6. So if someone said, what are the factors of 6? 2 and 3 would be among those numbers, okay? So next, the factors of 24. If you were going to list the factors of 24 and you wanted all of them, how I want you to do it is in the big U. When I took this, I had a concussion and everything was so hard to understand. And the teacher just thought that you could just instantly in your brain know all the factors of 24. Well, with my concussed brain, that wasn't happening. And so finally I learned a way to come up with all of them and not miss any by using the big U. Okay, this is how it works. Okay, so we're going to do the factors of 24. That was them, but I'm going to redo them for your viewing pleasure. Okay, so you start with number 1, because the first thing that goes into anything is 1. And so 1 times 24 is 24. Next, we try 2. And we ask ourselves, does 2 go into 24? Yes, it does. 12 times. How about 3? Does 3 go into 24? Yes, it does. 8 times. Does 4 go into 24? Notice I'm just going through the order of numbers. Does 4 go into 24? Yes, it does. 6 times. 6 times 4 is 24. It's one of the rhymey ones I like. Okay. Does 5 go into 24? No, it doesn't. And the next number in the order of counting is 6, which we already have. So we've gone around the big U and we know we're done. You're done when the next number is on the other side of the U, or like if you were doing factors of 25 and you got to 5 times 5, where it's the same number on the bottom. I needed that. I needed that systematic way of finding them all. I couldn't just do it in my head with my concussed horse accident brain, where the horse tried to knock my brains out by mashing it against the barn twice. All right, his name was Buck. He will live forever. Okay, in my tales of having a concussion. All right, it was my friend Becca's horse. My horse was Gypsy. She was much better mannered. She never tried to kill me. All right, so that's factors of 24. Now there's a whole nother thing called prime factorization. See, the names are too similar. We need to call this one the big U and that one the factor tree. Everybody would understand if we just call it big U and factor tree. Okay, so factor tree, we're going to get the prime factorization of 24. Well, let's talk about this word prime. A prime number is one that its only factors are itself and 1. Numbers like 2, the only factors of 2 are 2 times 1. That's the only way to get it. Numbers like 7, the only way to get it is 7 times 1. Those are prime numbers. The opposite of a prime number is a composite number. So prime numbers versus composite number. Composites have factors other than itself and 1. Okay? So if they ask for the prime factorization, what they want you to do is a factor tree. So this is how you do it. I'm going to write down, I got one here, but I'll do it for you live for your viewing pleasure. Okay? I think of 2 numbers, any 2 numbers that I can multiply together to get 24. And I'm going to do 2 times 12. 2 is prime, so that's the end of that tree branch. 12 is composite. I can think of 2 numbers that equal 12. 3 times 4 equal 12. 3 is prime, but 4 is composite. I can think of 2 numbers that equal 4. It's 2 times 2. Now every end branch of my upside down tree is a prime number, so I know I'm done. Now, could I have started with other factors of 24? Yes. We know there's others. I picked 2 and 12. I could have done 3 and 8. I could have done 4 and 6. I would end up with the same ends of the branches no matter how I started. So you get a little freedom here to pick whichever one you think of. Okay? So now that I've got this, these are the prime factors of 24. And I write them down in order as multiplying. So 2 times 2 times 2 times 3. That's the prime factorization of 24. But it's considered a little better etiquette, a little cooler, if you use exponents. So how many 2's do I have? I have 3 of them. So I could do 2 to the 3rd power times 3. Okay? Let's look at this one. 630. Now, in your book, they show you 2 different ways other than the way I'm showing you to do this one. So you can see that there's different ways. So this is, they asked for the prime factorization. That means they wanted a factor tree. And so I saw that this is even, so I knew 2 would go into it. So I said 2 and 315. 315 ends in a 5, so I know 5 will go into it. So I picked 5 and 63. 63, 2 times 3 is 6 and 3 is 3. That to me looked like 3 would go into it, and it does. It's 3 times 21. And I knew that 27 is 7 times 3. So these ends is the prime factorization of 630, and now I'm going to write it in order. Just the end. So the smallest one is 2. I circle it because remember my weakness, especially when I did this, was organization because of the concussion. So, and as a math teacher, I have found that organization helps all students, even those who don't have concussions. All right, so 2 is the first one. There's only 1 of them. Next is 3. And there's 2 of them, so I'll mark them out after I do them. And then comes 5, and there's 1 of it. And then 7, and there's 1 of it. So that is the prime factorization of 630. Now, another word of math is terms. So if we have like 3x plus 4, those are 2 different terms. They cannot be added together because to add or subtract, they have to have the same letters with the same exponents. If you just have 1 term, it's called a monomial. Mono means 1, so it's just 1 thing. 1 number with its letters. And it can have a bunch of letters, like 24x squared y squared is still a monomial. It's still considered 1 term. Okay, now this is another thing, is math books are inconsistent with these words. What makes it hard? The words. Do math books all agree on the words? No. And are they even consistent in the same book? No, because you had a problem that said to factor 28xy cubed. And what they wanted was a factor tree. They did not want the big U, even though they said they wanted factors. What they wanted and what they did was they did a factor tree. They wanted the prime factorization, but they asked for the factors. So, no, I'm not going to count it wrong if I'm grading your paper, but that's what frustrates me about math. It's not the math, it's easy, it's the English. Alright, so this one. If it has letters, you get to just ignore them and write them down in the prime factorization at the bottom. So that's easy, right? So all you have to worry about is the number. So 2 factors of 28 is 2 times 14. 2 is prime. 14 can split into 2 times 7. 7 is prime, so that's it. So I have 2 2's and 1 7 and 1 x and 1 y cubed. And that's the prime factorization, or the factors, is what they called it, of 28xy cubed. I think it's fun. I think when you do something like that, it looks like you are really smart. You are doing fancy math, and that's fun. All right, see you next time. Math is great.